Let's begin. Today's December 24th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 3, 7, 12, 19, 20, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our middle digit, the squared digit, and the Turing Machine compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our last digit, the circle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the value of the sum be less than 6? Should it be equal to 6? Or should the value of the sum be greater than 6? Criteria card E will take a look at our 3-digit solution, and the Turing Machine will let us know a little bit about its structure, so to speak. Specifically, it can inform us of whether there are no repetitions in our solution, as in the example 125, or it can let us know it's a double number, a digit repeated, as in the example 112, or it could be a triple number, a same digit repeated 3 times, as in the example 222. And finally, criteria card F again takes a look at our 3-digit solution from triangle to square to circle, and the Turing Machine will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 135, should they be in a descending order, or basically decreasing, as in the example 421, or could the 3-digit solution have no order? So let's take a look at the example of 231. Notice it goes from 2 to 3, it increases, and then it goes from 3 to 1, decreasing. Of course, you could have an analogous solution that is decreasing and then increasing, but basically it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, we have seen in previous puzzles another scenario where if you have consecutive equal digits, that can also exhibit no order. So if we look at this example from criteria card E, 112, notice that the ones are equal and are consecutive. They're next to each other. So the reason I say that they have no order is because when you go from the first one to the second one, there is no change. It neither increases nor decreases. So for that reason, I state that examples that have consecutive equal digits also have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice in circle. I did pick an even 4, but because the Turing Machine does not agree with that, it's actually letting us know that circle should be odd. So let's go ahead and type that up in our notes in section B. And again, we'll state that circle is an odd digit. And since it is odd, let's go ahead and cross out both evens. Okay. I think the next thing I'd like to test is criteria card D. Okay, so the Turing Machine does approve of my choice. In criteria card D, we're adding up the first 2 digits. So 3 plus 1 is 4. 4 is less than 6, and since the Turing Machine approves of that, it is true that the sum of the first two digits should be less than 6. So let's go ahead and type that up in our notes in section D. And we'll say that triangle plus square should be less than 6. And so what can we say? Well, if the sum of the first two digits is required to be less than 6, I don't think either of them could be a 5, because when you add 5, even to the smallest of 1, that sum is already 6. And of course, if you pick something bigger than 1, that sum will be greater than 6. Both cases are not acceptable. So we can exclude the 5s in both triangle and square. And I think that's about it, because 1 could be added to up to a maximum of 4, and that does give us a sum that's less than 6. And there are lots of other combinations that will give us that same sum being less than 6. Let's see, what else? Well, I'm wondering if... Yeah, let's go ahead and test criteria card A. Okay, so in criteria card A, we are comparing the value of a square, and my choice in square was 1, and 1 is less than 3, and the Turing Machine approves of that. So it must be true that square should be less than 3. So let's go ahead and type that up, and that's in our notes in section A, and we'll say that yes, square should be less than 3. Well, if that's the case, that means that we can actually cross out both 3 and 4. Okay. So let's see, how does that affect our triangle? Because, they are somewhat related based on criteria card D. So can we eliminate anything in triangle? No, actually, I don't think we can. That just basically eliminates 2 possibilities for square, but both 1 and 2 in square, with the exception, I guess, of 2 cannot be added to 4, but we can't cross it out because 1 is still a viable candidate. So I don't think we can do anything else. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card C, comparing our first and last digits. We also did not test criteria card E, basically letting us know if there are any pairings or no repetitions. And we didn't test criteria card F, the ordering of the digits. So if you recall from previous puzzles, I described a way where we can actually deduce criteria cards E and F. And the reasoning goes as follows. If you presume that the 3-digit solution is in an ascending order, meaning that the digits are increasing, and specifically, one thing I may have not stated, increasing uniquely, meaning you can't have, equal digits along the way. They all have to be ever increasing. Well, if they are uniquely increasing, well, that means that there are basically no repetitions, basically making this criteria card irrelevant, because you would know that if it's ascending, they are all unique. And likewise, if your 3-digit code would be in a descending order, right, ever decreasing, uniquely decreasing, again, there would be no repetitions. making this criteria card irrelevant. So we can then state that criteria card F, we can deduce that the 3-digit code should have no order based on that argument. So let's go ahead and type that up. We're going to deduce that the solution has no order. And similarly, we can use the options in criteria card F in the following way. If we know that a 3-digit code is a triple number, we would know that it would have no order because there is no change between the digits. It neither increases nor decreases, therefore making criteria card F irrelevant. And if you have a double number, well, that's one of the cases I mentioned at the top of the video. You do have consecutive equal digits, and again, there is no change between these first two digits. Now they could come at the end, meaning the middle and the last are paired up. Again, there would be no change between those two. And a third case is, what if that middle digit separated the pairs? So the pairs were in the first and the last. Well, that would be an increasing, decreasing, or vice versa possibility. And that again has no order. So that means we can outright deduce E to be that there should be no repetitions. So we're going to deduce that the solution has no repetitions. And so that means that they are unique. Okay, so we're looking for a unique solution. All digits are distinct, that has no order. So let's see. So if our solution is to have all unique digits, if triangle were 1, that would force square to be 2, because you can't have a repetition, which would then either produce a 3 or a 5 in circle. Well, not only is that going to be an ascending solution, it's also ambiguous, because I believe that triangle would always be smaller than circle. So you wouldn't be able to tell them apart. So it cannot be a 1 in triangle. So let's see what else. So what about if triangle were 2? Well, it couldn't be 2, 2. It would have to be 2, 1. Okay, that sum is less than 6. But again, how would you distinguish between 3 and 5? Triangle is less than both 3 and 5. So I don't think that could be a possibility. So let's go ahead and cross out the 2. What else? If 3 were then a possibility, let's see. 1 would work and 2 would work. Now that might produce unique solutions in that 3, 1, 5 or 3, 2, 5. But if that were the case, I think that would still be ambiguous. Let's go ahead, let's type them up here just to see them a little more clearly. So I'm saying it could be 3, 1, and then 5, or 3, 2, 5. Okay, so let's see. Our middle digit, yeah, of course, yeah, we already established that they had to be less than 3. That last digit is odd. In both cases, triangle, the first digit is smaller than the second. Their sum is less than 6, no repetitions, and no order. So I would say that these are ambiguous. You cannot have these. I can't tell them apart based on the criteria cards. So for that fact, I don't think it could be a 3. Which leaves us a 4, which means that square cannot be 2 because that sum is 6. So we're looking at 4, 1. And now it really, and if it's 4, 1, circle can't be a 1. So we do have 2 possibilities in 4, 1, 3. Oops. Uh-oh, let's see. Yeah, so it's continuing. So let's see, what if I go like this? Oh no, it's still doing it. All right, I'll put them up here then. So we'll say it's 4, 1, 3 or 4, 1, 5. And the distinguishing trait among those is that in the first case, triangle is bigger than circle, and in the second case, triangle is smaller than circle. So it's a 50-50. So, and I don't think there's any way you can actually distinguish or, deduce what it could be. So let's go ahead and we'll just say 4, 1, 5. Okay, and we're going to test criteria card C. Okay, it was a 50-50. We didn't guess the right one. So it cannot be 4, 1, 5. It must be 4, 1, 3. So let's cross that out. So let's go ahead and cross out the 5 in circle. And in C, we will say that, because it did not approve of triangle being less than circle, triangle should be greater than circle. So let's go ahead and type that up. And let's see. And they can't be equal because we know there are no repetitions. So I'm just going to type it up as we're going to deduce that triangle should be greater than circle. And again, that would be where triangle 4 is bigger than circle 3. So yeah, it looks like our solution is 4, 1, 3. All right, well, let's go verify that 4, 1, 3 is correct. Four, 1, 3. Fantastic. Well, how did we do versus the Turing machine? Well, this is a 6 criteria card puzzle, and we only had to do it in 4 tests. Outstanding. So that's pretty good. So let's go ahead and type up. We did A, B, D in the first round, and then C was the only thing we needed to test in the second round. So A, B, D in the first. So A was correct. B was incorrect. D was correct. And in the second round, we picked the wrong one, but that's okay. We learned from it. And so, wow, we beat the Turing machine by 3 questions. Well, no doubt it was recalling how criteria cards E and F play against each other, and we remembered that we could deduce each one outright. And so I've definitely started to incorporate that in my puzzle solving. I don't test them in the first round because I already know their interaction. So really, I just picked 3 out of the 4. And because I also knew that the ordering was going to be have no order, I knew that they were not going to be equal. So basically it made criteria card C a 50-50, and then I just used or tested criteria card A to help me whittle those options down. Well, what about you? How did you solve it? Did you recall this combo that lets us deduce one from the other? Or did you choose a different set of criteria cards, and did you discover anything interesting you'd like to share? Add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.